Okay, so my name is Won-Sung Lee, working for Korea Polar Research Institute. I'm gonna show and share something we have done and some plans for exploring what we can do for the Scott rings. And then this work is totally with the Alliance Consortium, which is a lot of contributions from over the world. So actually, we started from Western Antarctic, Western Rossi, just nearby the Jumbo station, neighboring Marizuchelli Italian station, and then Gondwana German station in Terranova Bay back in 2015, I guess. And then it's kind of like a typical cold ice shelf, cold cavity northern ice shelf here. And then we extended our research of interest to the Thwaites Glacier from 2019, which is that you know that they're like a warm water cavity, so we can have really good case studies we can do for in terms of like extreme end members, kind of like a process study, so the cold and the warm, and then a bit like a lazy to update that one, so still growing. So then like Scott rings is totally open to anyone, so come to join us and then collect and share the data. And as you can see here, we're not able to do everything without kind of like international collaboration to understand kind of complex system in the Antarctica. So this one is that even though all different aspects and then priorities we have, but the thing is that the overall overarching goal is to better understanding of the contribution of the Antarctic ice sheet to the future cellular rise. Everyone here already talking about it. And yeah, sure. LONI stands for Land Ice Ocean Network Exploration Using Semi-Autonomous Systems. Never remember. It's really long, but anyway, like, it's kind of catchy. Frozen? Right, okay. Yep. In terms of like a rings, what can contribute to the rings? So our focus region is that the grounding zone here, and then other components which directly affect that the grounding zone migration or the processes here. For example, cavity circulation or evolution of subglacial hydrology, which is kind of like beauty to the repeated survey, kind of like the Thwaites Glacier by the helicopter, what we are doing. It's really good for understanding what kind of like changes over time, hydrologic system in this area, and also kind of the warm water intrusion all the way to the grounding zone. So this is the primary target for us, and then also we're collecting the data underneath the ice shelf and then nearby the continental shelf, and also under the ice sheet around here by using the various kinds of the observation techniques here. And then this one is that what we are doing in the Antarctica. As you can see here, from the marine, the ocean, nearby the grounding zone, and also to the upstream of the ice sheet. So we're bringing all available the technologies to the field to get the invaluable data sets in the Antarctica. This is the location of the stations we built from 2011 from the scratch. We built our station, Jumbo station, opened the station from in 2014. And before that, we need to do some kind of like a site survey, so we deployed several passive seismic stations nearby. This one is the active volcano called the Mount Melbourne, and then Nansen ice shelf is here, and then Dragowski ice tongue, and then David Glacier up top here. And then this one is the Terranova Bay Polinia. So it's kind of like quite small. It's about like 100 kilometers and then 200 kilometers away. And then we put about 20 passive seismic stations and then GPS stations, a couple of ocean moorings here, and then ocean bottom seismic monitors, and other GPS stations again here. So very small and narrow region, but then we can test what kinds of like hypotheses in this region because we regularly visit this site, so we can do monitoring how it changes in this region, even though it's really boring to watch how it's like the changes in this region. We only saw the amount of changes in this region, but anyway, we can test and then learn a lot of technologies or the kind of like prove our hypothesis in this region. And then quite like a various kind of like the results we produced. Here the Antarctic shelf has really, what was that, the massive surface melting occurred back in 2014. And then another kind of thing is that the basal melting, basal channel drive kind of surface hydrology and also trigger rifting in this region. And also 2016, ice front calving happened, and then we had in situ observation, kind of like a precursor of the ice shelf, ice front calving by hydroacoustic monitoring system in front of the ice shelf here. Also from the passing seismology, we image that the magma chamber underneath the mountain, and then physical oceanography to understand the ice ocean interaction as well, and also heliborne ice radar system to identify the small scale of the previously unknown features underneath this ice. Probably yesterday, Matthew showed that the ridge found in this region, and then it helps us to stabilize the ice dynamics in this region. So even though heliborne, the ice survey is not providing kind of a lot of the spatial coverage, but you can see more detailed structure and the features around this region, and also we repeat the following the previous flight line, and then to compare what kind of like changes we have in this region. This one is that the cavity geometry. Tricky here did some kind of the gravity inversion study at Nansen shelf here, and then he did some kind of patchwork with shipborne bathymetry, high resolution bathymetry, and then inverted gravity stuff. So we have their understanding kind of what the cavity geometry looks like. This one is that the previously existing data sets, as you notice, as you see here, some places don't agree a lot, which is not surprising. So anyway, like it gives more insight to improve kind of the ocean circulation model, and then it could more kind of deal with data to how to the melt and the reef bridging stuff work the happening in this region as well. Let's move on to the Thwaites Glacier. We had two chances to visit Thwaites and the Pine Island Bay region back in 2019-20 and then 21-20 season, last season. 2 years ago, we had a bit like a lucky to get into this Pine Island Bay region, so we deployed several physical oceanography moorings and also other ocean bottom, some kind of like geophysical stuff here, and also visit some other kind of land-based geophysical stuff. Because at the this one is the research target region, because that one is the main trunk of the fast-moving ice shelf glacier, Thwaites Glacier, and then this is at the fast-moving, the retreating, the grounding zone here. So we put several APRSs and then GPSs and another tiltmeter as well. So this one is that 2 years ago, and then this year, as you can see here, this one is January probably 23rd. Then everything just like blocked by the sea ice and the large iceberg, so could not get into here. The thing is that we have is helicopters, so we could visit and then maintain the stations and retrieve the data, which shows some really interesting features related to the grounding zone processes, and also alternatively we visit near Thwaites Glacier. We call it Dustin. So we made a hole to access to the underwater, the ice shelf, under the ice shelf water, and then we deploy the I-through mooring here, and also some do airborne geophysics in this region as well, and then also closer views here. We put one continuous GPS station first monthly to have to measure the uplift rates, because of the previous study showed that it's really tremendous amount of the rate of the uplift, so which is closely related to the viscosity of the upper mantle. So the bedrock, we install the one station, and then we resurrect the one station that just like dead for years, and then we just like make it alive. This one is built peninsula, and then other geophysical stations, GPS, and on top of the subglacial lakes here. Then this one, why we chose that region is that as you can see here, the subglacial the rocky system just end up here. So probably we can find some kind of subglacial discharge, hopefully. And then original plan was that we drill a hole here with the drill system to make a direct measurement to have some signature of the subglacial discharge or the mixing, turbulence mixing in this region. But unfortunately, we were not able to fly over here. It's really far from here, so limited shoot time. So we just like cancel it, and then that's too late. We chose to make an isocam in this the region. And then this one is, as you can see here, how hard to get the in situ observation data in this region. So just without the international collaboration, we were not able to maintain the station quite like easily. This one is that our newly built, developed the Korean Antarctic project is that we called it KNOW. So we try to persuade our government to fund that while we need to continue our work in the thwaites or the other places. So what we're going to do is that we have to know now. So it's kind of like a 9-year project. So again, it's really long stuff. So still, I'm trying to learn that one. So anyway, it's kind of like it's going to happen from the 2023 next year. These are what we're going to like focus on more for the KNOW study. So uncharted area we're going to explore by using other quite like interesting stuff, and then probably Jamie will be talking more about detailed about like airborne deployment as well. The most important thing is that the people just like our money from the taxpayers, so they were really wondering if we're climate scientists, but we spent a lot of and we consume a lot of energy and fuel, so it's really become hard to convince and then justify why we are doing this kind of the monitoring or the collecting the data, consuming a lot of the energy. So we are asking my friend here to do something, and then also we need to develop an innovative way of reducing the energy power consumption stuff for the sustainable monitoring in this area. So where to go? Probably this one is still the provisional plans. The thing is that we're going to have 3 more times to visit in the thwaites region, and then this Tromsø Bay every year we can go there, and then probably 2 seasons we can visit somewhere around here. I don't know here. We cannot assess that the feasibility without kind of like international collaboration here. So that's it.